Welcome to Old School Chemistry. Today we're going to do the ALEKS topic, identifying oxidized and reduced reactants in a single displacement reaction. This is practice for you, okay? You have to know how to do redox reactions. If you don't, please go to my playlist and you're going to watch the redox playlist so that you can figure out how to identify what's reduced and what's oxidized. So really good practice for you. A couple of brief reviews. Remember our saying, Leo the lion says grr. Leo is lose electrons oxidation and grr is gain electrons reduction. That helps us because it feels backwards in our mind. We're identifying what loses, what gains, what's oxidized, what's reduced. Now our steps, first you have to identify, find those oxidation numbers. Second, you're going to link the oxidation numbers that change from reactants to products. Third, you'll determine what gains and loses electrons. That's the thinking part of it. And then lastly, you label, which means we can answer this question. So let's jump in and do those oxidation numbers. The chlorine is going to have a -1. That's going to contribute -2, has to equal a net 0. And the copper will then be a +2. Now honestly, in following my rules, there was no hydrogen, oxygen, or fluorine. I didn't have group 1 or group 2 elements, so then I went to the halogen to tackle our oxidation number. Now magnesium, an element in its elemental form, its oxidation number is always 0. Here we can use the alkaline earth metal, that is a +2. So if this is a +2 and I have 2 chlorines, that means that must be a -1 to contribute a net -2, and that would be our 0 net charge is a neutral compound. And then copper all by itself in elemental form, that is going to be a 0. So look at the oxidation numbers that change from reactants to products. We have copper goes from a 2+ to a 0. Magnesium goes from a 0 to a +2. This is where you have to think what loses and what gains electrons. Here's the trick that I've taught my students. I pretend that we have a vertical number line, and you start with 0. As you go up, you add electrons. As you go down, you lose electrons. So here, copper has lost 2 electrons. You know that when you see +2, there's 2 extra protons, it's lost 2 electrons. So +2. These oxidation numbers, remember, it really isn't that we've lost the electrons. It's our convention to figure out what does gain and lose electrons, okay? But you know that when we write +2, that's indicating we're down by 2 electrons. So if this is my 0, in your mind, I want you to picture 1, 2. We go down 2 steps, I lost 2 electrons. And then over here, copper is at a perfect 0. It hasn't gained or lost electrons. So look at the difference. I'm down by 2, now I'm at perfect 0. What happened in that process? Down by 2, at perfect 0, we gained 2 electrons. So gain 2 electrons. And then in my head, I say, Leo the lion says grr. Gain electrons reduction. So that means the copper is reduced. Okay, nice. Now we can stop right there. We can stop right there. But let's go ahead and finish it just so that you get the practice. Magnesium, perfect 0, goes to a +2. +2 means I've lost 2 electrons. I'm down by 2. So 0, down by 2, what happened? It lost 2 electrons. So let's do lose 2 electrons. And then I think Leo the lion says grr. Leo, lose electrons, oxidize, oxidation. So this has been oxidized. Okay, now typing these in, you're going to type in the reactants. Okay, type in the reactants. So the reactant that is oxidized, we determined is magnesium. And the reactant that is reduced right here is the copper 2 chloride, and you have to put in that full compound. You can't just do copper. You and I know it was the copper atom that was reduced, but you have to put in the full reactant, the CuCl2. Now, a hack on this. Every single one of these is a single replacement reaction. Right there, it says it in the name, single replacement reaction, the name of this problem. In single replacement reactions, you always have the metal switch places. So compound, metal, metal, compound. Do you know what that means? Always your metal by itself that's reactant, it will always be oxidized. it will always go from a 0 to a positive charge, which means it loses electrons. And the metal in the compound will always be the reduced. It's going from a positive charge, metals are positive, to a 0, which means it's gaining electrons. So you can look at this really, really fast. I go, oh, the sodium, that metal's going from the 0 to a positive, right? I don't even care what the number is. It's going from a perfect 0 to I've lost electrons, a positive. That's oxidized. And this is going from some positive to a 0. I'm going from I lost electrons to a perfect 0. It's always gained. And that's the reduced. So I do zinc chloride. And then you do this a couple of times and you get really fast, where you say, oh, the zinc, that is going to be my oxidized, and the iron 2 sulfate, that's going to be my reduced. So it's really not a chemistry thing. It's not really learning. That's just a trick with ALEKS itself, because these are all single replacement reactions. Here's working it, thinking it out. Once you understand that, then you could do the fast trick. All right, good job. So proud of you. Have a wonderful day. Please like and subscribe if you haven't already, and I'll see you next time. Bye.